Today's review will be on slope and graphing linear equations. So let's go ahead and start with number 1. We're going to graph the linear equation y equals 5 halves x plus 1. Remember, there's two things we want to identify, which are 1, the slope, and b, which is your y-intercept, remembering that an equation is of the form y equals mx plus b. So your slope is always a number next to the variable, usually will be a fraction. The y-intercept is a number that does not have the letter next to it. And again, you can only identify slope and y-intercept if you have y equals. So if it's not y equals, you don't know what the slope or the y-intercept are. So let's go ahead and graph this. Always start with your y-intercept because that's where it crosses the y-axis. I'm going to zoom in on this. So in this case, we have our y-intercept at positive 1. So we're going to go up 1 on the y-axis. And from there, we're going to follow the slope. 5 is rise. 2 is run, so we're going to go up 5 and over 2. So like 1, 2, 3, 4, 5, over 2. And we go ahead and put our point there. We can also go backwards from the y-intercept, down 5, and backwards or left 2. And we just go ahead and connect our line. So again, just a quick review of what we were going over last semester. This will be tested on your interim, knowing how to identify the graph of a line. Again, line should be going up or increasing because the slope is positive. Let's go ahead and move on to number 2. So on number 2, we have 5 lines graphed for us, and we're going to identify which segment has the smallest negative slope and which one has the largest positive slope. Remember, negative tells us that the line should be going down. So it's going to be between this line here. This line's also going down, and this one over here. So we have 3 lines going down. So it's between these 3 lines. Let's just label them A, B, and C. We'll call this one D and F. So between A, B, and C, which one has the smallest negative slope? So we want the one that is the least steepest, or the one that has the smallest angle on it. So as we can see, A is actually really steep because it's at a large angle. B is kind of steep, and C has the least angle on it. So C would be the one with the smallest negative slope. Let's look at the other two to decide which one has the largest positive slope. So which one has a bigger angle? So between D and F, the one with the largest angle would be D. So as we see our answers, positive slope, negative slope depends on the direction, up or down. Steepest, so the steeper the line is, the more of an angle or more incline that it has. All right, let's go ahead and move on to number 3. We'll clear this out and scroll down. So here's number 3, 4, 5, and 6 and on. So let's go with number 3. So we're going to go ahead and answer the question, what is the slope of the linear equation? So here we have a line that's already been graphed for us. We just want to identify the slope of it. So just what does m equal, or what does the slope equal? So we're going to start at the y-intercept, so we just label a point there, and then we have to find a second point that hits at a very, very nice spot. So like if I were to pick a point like right here, it wouldn't work because it's not on the actual grid where 2 lines intersect that are already labeled for me. So I don't want to use that point. If I go over again, I can see that this hits perfectly nicely. If you didn't choose that one, you could have picked this one right here, or you could have picked a point here. So any of these points that I'm marking down right now are acceptable points to identify the slope. So usually we will go with the one that's closest, so I'll just go with the first one I put. And then from there, we're just going to count my rise over my run. In this case, the rise is 1 and the run is 2. We write it rise over run. Remember, rise over run. So my slope here is 1/2. Now you may be wondering, what if you didn't pick these 2 points? I'm going to clear this out and show you another way of doing it and still getting the same answer of 1/2. So let's say you did not pick that point there. Let's say you picked a different point like this one over here. So you would still work it the same way. So rise over run. Here you would have a rise of 2 and a run of 4. So your slope would be 2/4, but since we picked the further point, we would reduce this to 1/2. Same answer. All right, let's go ahead and clear this out and move on to the next problem. Let's look at number 4. What is the equation, and that's a typo, of, not at. So let's fix that up. Of, it's not working, there we go. Of the line, and I think I wrote it right. What is the equation of the line? Well, let's just erase all of this actually. We don't need it. Of the line below. So what is the equation of the line below? So again, start on the x and then the y-axis to identify our y-intercept. Remember, we want to do y equals mx plus b. And we know our b is -1, so we know this is -1. Now we have to identify, let's bring down our x, our slope. So we're looking for that one point on the line that hits perfectly. Again, something like here would not be correct. So we're just going to look down this line and see where we find a point. And if we keep looking, if you found it here, that's a good point right there. Another good one would have been, let's see, right here. So I'm going to label a few of them here. It doesn't matter which of these you actually labeled. They all actually work. So we're going to go ahead and count our rise over our run. So this is the rise over the run. It'll be the same thing here or there. Doesn't matter which one you pick. All right, so let's go and count. So the rise is 3, but since it's going down, it's actually -3. Remember, this line is decreasing. Abbreviate that. So it should be negative. The run is 2. So my slope is -3 over 2. And that's how I write the equation of a line. Y-intercept and the slope. Let's go ahead and move on to the next problem. Let's go to 5 and 6. So looking at number 5, we're asking for the slope again. This same word again. We're looking for the slope of the linear equation, but instead of giving me the graph, I am given the equation. But unfortunately, it's not in y equals mx plus b. So that means I cannot just tell you what the slope is. This is giving me trouble. Here we go. So because it's not in y equals mx plus b, I don't know what the slope is by just looking at this equation. So what I'm going to need to do is modify this equation and rewrite it, reorganize the order in order for the y to equal the mx plus b. So I need to solve for y. So I need to get y by itself. So again, just go ahead and start solving. Things need to move away from the y, so I'm going to start by moving the x term first. So I'm going to subtract 6x on both sides. The 6 does not combine with the 18, so I'm going to separate it. Then I'm going to go ahead and drop my y. Common mistake is to do this, just y, but we cannot forget about this negative here. So we have to bring it down as well. Bring down the 18, bring down the -6x. Do not put 12x, because that's a common error. Again, since I have the y with a negative in front of it, I need to divide by a negative, or a -1 if you want to put an invisible 1 in there. So that helps put it, but we always divide by a -1. Everything gets divided by -1, whether you do one giant fraction or do 2 individual -1s. Both will work. So then y equals -18. On the right side, 2 negatives make a positive, so we get +6x. Now the question is, which of these two numbers is our slope, because that's what they are asking us to solve for. Remember, our slope is next to the letter x. Even though it's backwards the way I wrote it, that means this piece has my slope, which is, the slope is m equal to just 6, not 6x, but just 6. All right, let's go ahead and move on to the next problem. Number 6. Which asks what would the slope of a line be that passes the points 1, 2, and 10, 5. So again, we're being asked for the slope again, but this time I'm being given 2 points instead of a graph or an equation. So I'm given to do the same task, but with a different set of given information. So if we want, we can actually go ahead and graph this, but again, I do not want to have to draw all these lines and then count everything. It's going to take too long. So it's easier just to use the rule, which says slope is the change in y, which is a rise, over the change in x, which means the rise over the run, again. You probably wouldn't write all this down if you were doing this problem. That's not run. And change in y means the difference of the y's versus the difference of the x's, which means we're going to subtract the y's and we're going to subtract the x's. And you usually see subscripts on them to distinguish the two y's with the two x's. So just if you want, go ahead and label the numbers. This is x and y. That's x and y. We'll call these 1 for the first point, and we'll call these 2 for the second point. So my slope, again, the part in red is probably where you would start on a test, unless you need to refresh your memory and write all of this out. Top, we subtract the y's. My y's are the 5 and the 2. So second minus first, or first minus second. If you put these backwards, it should be perfectly fine. And the bottom is subtract the x's, which is going to be the 10 and the 1 in that order. You've got to be consistent, the 2's minus the 1's, or the 1's minus the 2's. So my slope will be 5 minus 2 is 3 over 9. Always reduce fractions if possible, so we can divide these by 3. So we're going to get 1/3 as our final answer for our slope. Again, if you would have graphed this and put the 2 points and connected the line, you would have counted rise over run and gotten the same answer. All right, let's move over to the next problem, which is number 7. Let's go. Here's number 7. All right, so let's look at number 7. So which scenario best explains the representation of the graph on the right side? We know the point 0, 30. So this point right here, that's 0, 30. You can see it hitting the 30 on the y-axis. And for 50, so they just gave us these 2 points, so we know exactly where they're at, are located on the line. You can tell by just looking at it as well. So it says Laura has no money in savings and saves $30 per week. So again, this one says she starts off with no money, but looking at the graph at time 0, which is this right here, we see that she starts off having, that's her starting value or her y-intercept. She starts with 30 bucks, so it cannot be A. B says Laura has no money again, but again, we know she's got $30. So the next one says Laura starts with 30 bucks, that's good. D says Laura has $5, which she doesn't, it doesn't start at 5. And Laura has $30, so it's between C and E. And we're seeing that this is growing up and over. And it says, and saves $5 per week, or she's saving $30 a week. So looking at the graph, we can see that from week 0 to week 1, she earned $5 because it went from 30 to 35 to 40 to 45 to 50. So she is earning $5 per week. So our answer would be C. Let's go on to the next one. And the last 2 at that. All right, so a 3-foot tree is planted and grows 5 feet per year. The equation y minus 2 equals 5x can be used to represent the height of the tree. We're going to graph this situation. So in this case, we're going to stick to the positive axis. The x-axis will represent the time. That's not coming out. Let's try it again. The time in weeks. And the y-axis will be the height. I'll just put an H for height. Well, let's actually write it down. So time on x-axis, height on the y-axis. So we know we start at 3 feet. So I am going to go by 5s on this. I'm just going to change the scale just to make it easier. And I'll stop at 20 here. You can label the rest. So we start at 3 feet. So it'll be somewhere like right here. And then it's growing 5 feet per year. So it's going something like this. And then we just go ahead and connect it. So this is pretty much our graph. And actually there is a typo on this thing. So can you guys go ahead and change this to a 3 right here. It shouldn't be a 2, it should be a 3. All right, let's go ahead and move on to the last problem. And we have this right here. Andrew spends $200 on supplies for his business. He sells the product for 25 bucks. Sketch a graph that represents the situation. So on this one, I'm actually going to split it down the middle and make this my, let's see, this is the cost here for the y-axis, and then the number he sells of the product he sold. So he starts in the negative, so we'll go by 50s. This will be 50, 100, and this will be negative 200 right here. So he starts off at a deficit because he spent money. So he has 0 here. At 0, he's got negative 200, and he is selling for $25 per week. So after 1 week, he's made $25. After 1 week, after one item sold. So after each item is sold, he goes up by half a box, which is 25. So it'll take him a while before he actually gets there. And this represents his graph. So again, he starts at negative because he's got to work his way up to go back to 0 and then eventually make a profit. So his profit will be at this point right here. All right, so go ahead and start working on your practice problems. Good luck.